Greetings to you, dear participants of workshop. I present to you attention the work Web Application for Facial Wrinkle Recognition by authors duet Elena Tarasova, speaker, and Iryna Mintii. Face detection technology is one of the main trends of recent years. The most ambitious practical application of face recognition with the help of a computer is the creation of anthropometric robots that can read the emotional state of the interlocutor. Algorithms for recognizing a human face are different in complexity. Identifying a person in image using a computer means solving two different tasks. The first one, to find a face in the image. The second, to find in the image those features that distinguish a particular person from other people from the database. Face detection algorithms contain at the input of the image, at the output, the coordinates of the found rectangle of the person in the coordinate system of the image. This approach is used in the analysis of a photo and video content. Attempts to teach computers to find faces in images began over 60 years ago, but the most important step forward was the creation 30 years ago by Paul Viola and Michael-Jones of a cascade amplification method called Viola-Jones object detection. Face detection is one of the methods of identifying a person, but over time the process of aging and changing facial features requires the updating of existing database, which is a cumbersome procedure. To solve this problem, it is necessary to apply a method that identifies a person regardless of the effects on the face of aging process. The initial our task was to prepare a web application for a system for assessing the psychological characteristics of a face from image. Physiognomy of a face is a complex psychological tool for diagnosing a person by appearance, primarily by the face. The facial muscles are a kind of keyboard that conveys our emotions to others, from happiness and joy to fear and anger. As a result of our work, a software package was created for recognizing a face in image and determining wrinkles on a face. We created a web application using the Django framework, Python language, OpenCv and Dlib libraries to recognize faces in the image. The implementation of computer vision can be done using the OpenCv library. This library provides tools for processing and analyzing the contents of image, including the identification of objects in images, object tracking, image transformation, application of machine learning methods, and the discovery of common elements on various images. The following functions of the described library were used: the Viola-Jones approach to face detection and functions for working with images, the filtration and transformation. The Viola-Jones algorithm can be divided into four main stages. Translate the image into an integral representation. Use the hair attributes as descriptors. Use the ADA boost as a classifier. Use the cascade from the classifier. Let's consider each of these stages in more detail. In order to reduce the number of operations for computing the hair-like features, the original image is translated into its integral representation. This view allows to quickly calculate the total brightness of the rectangle in the image regardless of the size of this rectangle. Integral representation images isometrics, whose size is equal to the original image and the value of its element is calculated in the following way. Each element of the matrix is the sum of pixels in a rectangle. The calculation of such a matrix takes linear time, which is proportional to the number of pixels in a given image. Therefore, the integral representation is calculated completely in one pass. Let us demonstrate visually the calculation of the area of a rectangle in an integral image using the following example. Suppose that in the integral image you need to find the area of the rectangle with vertices ABCD. This calculation can be reduced to just 3 operations. In the classical Viola-Jones method, the high-like features are used, which are represented in the slide. These features are calculated on the following way. Actually, for this purpose, the integral representation of the image considered above is used. The AdaBoost algorithm is used to select useful features. Boosting is a complex of methods that contributes to improving the accuracy of analytical models. This cascade model of classifiers is very well suited for processing images that contain relatively small detected objects. In this case, the classifier constructed in this way can quickly decide that this area does not contain an object and proceed to the next one. So summing up the above, the Viola-Jones algorithm involves the sequential execution of 4 steps. Remove the color and convert the image to the matrix of brightness. Impose one square black and white masks on the resulting matrix, the high-like features. Inspect the entire image with the mask by changing the position and size. Add the numerical values of the brightness of those matrix cells that fall under the white part of the mask and subtract the values that fall under the black part. If at least in one case the difference between white and black areas is above a certain threshold, check this area of the image for further work, and if not, forget about it, there is no face here. Repeat from step 2 with a new mask, but only in the area of the image that passed the first exam. Our work uses a face detector from Dlib library. The detector is used to estimate the location of 68 coordinates that are displayed on the face. Indices coordinates are indicated in the slide. These points are part of the data set on which the face detector predictor was stored. Finding the key points of the face in the image, this can be done using different methods. It is enough to use an approach that creates a limiting frame around the face. Apply the shape predictor, in particular the key-point detector, to get coordinates of the faces. Anatomical guidelines were used to implement the wrinkle detection algorithm on the face image to evaluate different types of wrinkles. According to the control points, the faces are divided into parts where wrinkles are to be found. The filtered area applies to the area under consideration, depending on the location of area of the face. At the next stage, contours are determined and the geometric parameters are analyzed. Wrinkle is considered valid detected if the contour parameter meets the requirements for each type of wrinkles. For symmetrical, an additional double-sided check is used. The results are shown in this slide. To train the model, we use a standard Dlib dataset IBAC, which consists of over 6,666 images of different dimensions. The official Dlib dataset consists of a combination of 4 main datasets. It is possible to select custom images from social network and news. The total dataset for training the model was 20,000 images. In this paper, we have shown that different types of wrinkle on the face image are conveniently recognized by using special filters. For example, to detect small wrinkles using the Gaussian filter. For strong wrinkles, it is better to use a Gabor filter. In our work, an algorithm for determining the presence and location of various types of wrinkles and determining the geometric location on the face is implemented. We created a web application using the Django framework, Python language, OpenCv and Dlib libraries to recognize faces in the image. Using the program, you can get geometric parameters of wrinkles. This application can be used to develop a face-to-face identification system for research in the field of cosmetology and as the basis for creating a system for recognizing emotion. Some information about us. Thank you for attention.